Welcome all. Today, let us have a look on how a certain number of RAM chips are connected within a computer to the CPU. In this example, we are taking into consideration the main memory. This main memory consists of four RAM chips. Each RAM chip is of size 128 into 8, and we are taking one ROM chip which is of size 512 into 8. So they together form the main memory of this simple basic microcomputer, and this is the main memory. And here we are saying there is a CPU, and we have to learn how the connections will be there between this main memory and the CPU. What is the layout of buses between the two? So there will be obviously three kinds of buses. There will be the control buses like read write, where the CPU will tell the main memory whether to read or to write. There will be the address bus, which will specify which address the CPU wants to read or which address it wants to write. And thirdly, there will be the data bus, through which there will be the data transfer, either from the CPU to main memory or from main memory to the CPU. In this diagram, we can see that every chip will have a bidirectional data bus, and it will be connected to a common data bus that will go to the CPU. The bus is common because only one chip can transfer data at a time. So there will be a single common data bus, and the size of this data bus will be 8 bits, which is same as the length of one word of data in the main memory. Since in each chip it is 8, so the width, the size of this data bus will be 8. Okay, then if we consider this RAM, for example, it has 128 words in total, which means it will have 7 address lines, because we need 7 bits to address 128 memory locations. So 128 word length means there will be 7 address bits. So this is AD, the address lines are 7. In this RAM also, the RAM 2, it will be 7. In third RAM 7, in fourth RAM 7, and since the number of words in ROM is 512, therefore it will be 9, because to address 512 locations we need 9 bits. Okay, so the CPU will produce an address. If we name the address bits that the CPU will produce, or the address lines that the CPU are coming from the CPU, let us call those address lines as 1, 2, 3, 4, and let us suppose that they go up to 16. So we have 16 address lines coming from the CPU, which together form the address bus. So obviously, since this is 7, RAM needs 7 address lines. So the first 7, 1 to 7, will go from here. You can see they are going to AD7 of RAM 1. Same 7 lines will also go to AD7 of RAM 2 and AD7 of RAM 3, and the same 1 to 7 address lines will go to the AD7 of RAM 4, and the same 7 will go to the address lines of ROM. But we know that the ROM here needs 9 address lines, so it should be 1 to 9. So this is 1 to 7, and it will also require 8 and 9. So this is very simple and logical, that the address lines required by the ROM will be 2 more than the RAM. So 1 to 7 plus 8 and 9 will also come into ROM, making the address bits, the address lines of ROM equal to 9. Okay. Now, since there are 4 RAM chips, if a CPU gives some address, how will we come to know which RAM address it is talking of? If the CPU says address, for example, 7 in terms of decimal, we don't know which 7, the 7 of RAM 1 or 2 or 3 or 4. To clarify this thing, we need extra 2 bits, because we have 4 RAMs. To distinguish between 4 things, we need 2 bits. So those 2 bits are this 8 and 9. So among the address bus, 8 and 9 will be used to distinguish between 4 RAMs. To distinguish between 4 things, we use 2 bits, that is fine, but an easier way to select one of the 4 is to use a decoder. So what will be the size of decoder? Since it has 2 inputs, 8 and 9, so its size will be 2 into 4, which means there will be 2 inputs and 4 outputs. And that is what we require, because we have 4 RAMs, so we need 4 outputs. How does a decoder work? Very simple. If 8 and 9 bit, if these two lines are 0 0, then the first output of the decoder, this 0th line, will be on, other will be off. This will be 1 and other will be 0. So because this is going to this RAM CS1, so automatically RAM 1 will be selected. If the 8th and 9th bit are 0 1, then all will be 0 outputs except this one output. So automatically RAM 2 will be selected. If this is 1 0, then this will be on, others will be off. So automatically RAM 3 will be selected. And the last condition 1 1, this will be on, others will be off, which means RAM 4 will be selected. In this way, we can differentiate between the 4 RAMs. Now, again a question arises that if the CPU gives us a certain address, is this address of RAM or is this address of ROM? So again, we have two things, RAM or ROM. So to decide between two things, we need just one bit. If that one bit is 0, RAM will be selected. If that one bit is 1, ROM will be selected. So we need this 10th bit. So this 10th line, we can see it goes to CS2 bar. Here also in RAM 2 again CS2 bar, in RAM 3 again CS2 bar, in RAM 4 again CS2 bar. And we know that whenever there is bar, it means that this chip will be selected when the input is 0. So when the 10th bit is 0, RAM will be selected by this 10th bit, and if it is 1, then we can see here is a NOT gate which will convert this 1 into 0, and by this 0 ROM will be selected. So this is a very logical and simple thing, that the 10th bit will decide whether the CPU wants to access RAM or ROM. If the 10th bit of the address bus is 0, RAM will be selected, and if it is 1, ROM will be selected using a very simple circuit and a NOT gate here. And then there will be those this extra lines will not be used in this case. From 11 to 16, 10 lines are sufficient. And there is the read write, which is the control lines, and obviously read and write will go to each RAM. Read and write, read and write, same read and write line will go to each RAM. And to ROM, the only this read line will go, and it will go to CS1. So whenever read is on and the ROM is selected, it is obviously this ROM thing will be selected and reading will happen, and it will be a unidirectional data bus. This ROM will have a unidirectional data bus because this is read only memory. So this is the whole organization of this main memory with respect to CPU. Let us take some numerical problems. So the first problem says, how many 128 into 8 RAM chips are needed to provide a memory capacity of 2048 bytes? So the question is, the total capacity that we require is 2048 bytes, and what we are provided with? We are provided with RAM chips, and each RAM chip is 128 into 8. So let us solve this numerical problem. So let us see the part A first. So the required memory capacity according to the question is 2048 bytes, which is 2048 into 8 if we put 10 bits. The size of each RAM chip is given. It is 128 into 8 bits. So now this is a simple question of mathematics, that how many RAM chips we will require. Total we require this much size, and we are provided with this much size chips. If we divide the two, we get the answer. So the number of RAM chips needed will be this 2048 into 8 divided by 128 into 8. which comes out to be 16. So the answer is 16. Let us see the part B. How many lines of the address bus must be used to access 2048 bytes of memory? So now we have 2048 bytes of memory. So how many address lines will be used for 2048 bytes of memory? In other words, we have 2048 words of memory. Each word is 1 byte. How much address lines will be needed to address 2048 things? How many lines are required? 11 lines are required if we need to address 2048 bytes. So there are multiple ways of doing it. One way is doing it directly. For example, we say for addressing 2 words we require 1 bit. For 4 words we require 2 bits. For 8 we require 3. For 16 we require 4, and so on till we reach 2048, which will require 11 bits. Or we can also do it using this formula of log. So lines of address bus needed to access 2048 bytes of memory will be equal to log 2048, log of what number of words are there in the memory. But the log is to be taken to the base 2 because we are representing them in binary. So log to the base 2 2048, we can directly calculate, or you can do it stepwise. Log 2, then 2048 can be written as 2 raised power 11. We know that log of m raised power n is equivalent to n log m, and this thing obviously will be 1, and answer is 11. Another part, another is of this B part is how many of these lines will be common to all chips. So how many lines will be common to all chips? So let us see what is the size of a chip. The size of a chip is 128 into 8. Since the size of one chip is 128 into 8, that means each chip has 128 words. Since each chip has 128 words, so to address 128 things, we need log 128 lines. So which comes out to be 7. That means to each RAM chip, 7 lines will be going. So in total, we have 11 address lines, out of which 7 will be going to each RAM chip. And very obviously, where will the next remaining 4 go? The remaining 4 will be used to distinguish between the RAMs. Since we have 16 RAM chips, to distinguish between 16 RAM chips, we require 4 bits. So the 4 bits will be required to distinguish between those 16 RAM chips. So that is, let us see this part C. How many lines must be decoded for chip select? Specify the size of decoders. So for selecting the chip, how many lines we need? We need 4 lines because we have 16 chips. For distinguishing between 16 chips, we need 4 lines. So lines to be decoded for chip select will be 4. In other words, these 4 lines will go to the decoder. And what will be the size of decoder? Obviously, if the input of decoder is 4, the output will be 16. So the size of the decoder will be 4 into 16. Let us take up another problem. It says a ROM chip is of 1024 into 8 bits. So there is only one ROM chip and it is of this size. And this ROM chip has 4 select inputs. So there are 4 selection lines going in, and this RAM chip, obviously every chip needs a power supply, so this RAM chip needs a 5-volt power supply. The question is, how many pins are needed for the IC package? So how many pins will be there? Very simple. Let us first see how many address lines will be there. Since the ROM is of 1024 words, so to address 1024 things, we obviously need 10 bits. So this ROM chip will have 10 address lines. How many data lines will be there? It is here 8. So 8 data lines will be there because the size of one word is 8. And what about power lines? It is given that we need a 5-volt power supply, and if there is a 5-volt power supply, there must be a ground also. So power lines will be 2. And what about chip select lines? It is given that there are 4 chip select lines. So chip select lines are 4. If we add all these lines, 10 plus 8 plus 2 plus 4, it comes out to be 24. So in this chip, total there will be 24 lines. So in other words, the IC package of this chip will have 24 pins. Thank you.